All right, MAP4C, day 2, lesson 1.1a. This is part 2. We just finished example 1 and now we're on to example 2. Example 2 is Ferd's deck. Again, Ferd's deck is going to be 20 inches off the ground. The steps must have a maximum pitch of 40 degrees. Must be some sort of safety code or something like that. How far out do the stairs have to begin to meet safety code? So I think we need a diagram here first. It doesn't have to be perfect, but there's the ground. This is Ferd's deck here. Right there, Ferd's deck. There's the top. It says the deck. It's going to be 20 inches off the ground. So this is 20 inches. And they are supposed to have a maximum pitch of 40 degrees. So the steps are going to go up to the deck at a maximum angle of 40 degrees. So that, to me, says that that angle there is 40. I don't know much about construction, don't know much about pitch, but I'm pretty sure that's 40 degrees right there. And, you know, the steps are going to go in there, but we don't really care. It's just sort of the slope of the steps are supposed to be at that angle. And we want to find out how far out the stairs have to begin. So there's where they begin. So it's kind of like this is the minimum. If this is 40 degrees, you know, if X is more, we're going to get an angle that's less, and that's fine too. But hopefully Ferd's deck is coming straight out of the ground, so we get a 90-degree angle there. It's not a very good 90-degree angle, but we don't really care too bad. This isn't a Pythagorean theorem example. This is SOHCAHTOA, right? We've got an angle and a side, and we want to find another side. We've kind of got to figure out what sides we're given and which ratio we should write down. So this is a SOHCAHTOA question. All right, well, from this angle, the given angle, well, what sides do we got? Remember, the 90-degree points at the hypotenuse, right there, but we're not using it. And there's no, you know, that's not one of our givens, and that's one of our unknowns. We don't need it at all. What are the other two sides? Well, next to the 40-degree angle, that's the adjacent side, and through the triangle, this is the opposite side. And so opposite and adjacent, which one are we going to use? That's opposite and hypotenuse, not that one. Over here, opposite and adjacent, we're going to use the tangent. So we're going to write down the tan of 40 degrees is opposite over adjacent. I'm just going to substitute in. Opposite is 20. The adjacent side is what we want to find. Now we got to solve this. The x is on the bottom. That's weird. If it was a number, we just multiply. So that's actually what we're still going to do. I'm just going to cross multiply. X gets multiplied up there, and it's gone on this side. There's the opposite operation of divide is multiply. So it's multiplied there. But now we got to get x alone. We've got to get rid of this number. Now we could fire that into a calculator and have a decimal, but really we're going to divide by whatever this is, right? So on this side it'll cancel. On this side, well, that's what we're going to actually put into our calculator, right? We're going to have x equals 20 divided by tan 40, and you wouldn't probably write that step in. You'd just go 20 divided by tan 40, put that on into your calculator, and it's 23.84 inches. 20 divided by tan 40. Now, this looks weird. Sure, this is 23 inches. The 0.84, that's difficult to measure, right? We got to figure out so we can say what's 0.84 inches. And essentially, we could sort of figure out what fractions. We know inches are in fractions of, you know, halves, quarters, and eighths, and sixteenths, and, you know, and so on. If you want to become more accurate, in Mr. Colling's class, it might be 32nds, 64ths, you know, smaller and smaller and smaller fractions. But if we wanted to figure out what fraction is, well, you could say that's about 3/4, right? 3/4 is about 0.75, right? Is 3/4. But if we wanted to go the next one, we could just take the 0.84, if we wanted to, multiply by 8, and see how many eighths that is. It ends up being 6 and a little bit. about 7. So we could say that the steps should start 23 and 7/8 inches out. Now, on a test, I'd probably take the decimals. And your book always just gives decimals of inches, which would give Mr. Faber a big frown. But I'd probably be tempted if you got your answer as a decimal and wrote that on the test to give you a bonus mark for that, because well, it's smart and it's more accurate, in the construction world. Example 3. Now, back to a boring old math question. This is actually not part A. This is just the only question here. We've got, oh, hang on, we've got 2 questions. Oops, it's not just part A. All right, well, here we go. In triangle XYZ, we've got some stuff. Calculate length Y. All right, well, obviously we need to draw a diagram. We got to be careful when we draw this diagram where we put the 90-degree angle, right? So here's XYZ. And I'm going to label it XYZ. Oh, hang on. Y is 90, so this is the 90-degree angle. I'm going to write that first so I know which one. After that, the X and the Z don't really matter, as long as the Y is the 90 degrees. And I can see now angle X is 16. That's 16 degrees there. And little z is 7.6. Little z. Now that's not this angle. That's the side. The little letters are sides, remember. And we want to find length y. We want to find length y. That happens to be the hypotenuse, doesn't it? Well, what are we given with respect to this triangle? From this angle, we know that this is the hypotenuse. Change color here. That's the hypotenuse. And from this angle, what side's that? Well, through the triangle is the opposite. This is the adjacent side. So which trig ratio we're going to use? Adjacent and hypotenuse. There it is, adjacent and hypotenuse. We're going to use the cosine of 16 degrees is adjacent over hypotenuse. And we got another one of these ones with the unknown on the bottom, cross multiply. Divide by the cos of 16 degrees. And I prefer not to put that into my calculator until the very end. See, I'm going to put 7.6 divided by cos 16 into my calculator in one step here. 7.6 divided by cos of 16 equals, I got about 7.9 centimeters. 7.9 centimeters. And over here, part B, find angle A. Well, angle A, from angle A, this is the opposite side. This is the hypotenuse. It's the one that's getting pointed at by the 90-degree angle. And so opposite and hypotenuse, sine. Sine of angle A is opposite over hypotenuse. Oops. Opposite over hypotenuse. And that I'm actually going to put that into my calculator. That's the easiest thing to do, I'd say. And then I go 4.8 divided by 6.3, and that's about 0.7619 in decimals. How do I get an angle? Remember, I got to get rid of the sine. I got to do the opposite operation of sine, and that's that second function business, right? That's sine minus 1. First time we saw that this year, but you should remember that from grade 10, grade 11, and so on. That's an approximate answer, and that's actually approximately 15 degrees. And how we get that, just in case you need a little refresher, usually second function on most calculators. Oops. Mess. On most calculators, it's second function button, something like that, or INV maybe, and then you hit your sine key. As soon as you hit the second function, that gives you the little thing that's above it, usually sine minus 1. Sometimes this might be INV. All right, that's it. On to homework now.